My name is John Harvey. I'm a software engineer at Kabam. I have slides for that, so let's just get into it and do slides. Why am I here? Well, the big question is, why is Kabam here? Why does mobile, blah, blah, blah. So I want to give you an overview of what mobile gaming is compared to the other types of gaming that are out there. Mobile's the kind of purpley color on the left there. When I started in mobile gaming 5 years ago, it wasn't that large of a slice. Who knows what it'll be another 5 years from now? Maybe the console wars will finish and it'll become huge. But at the moment, mobile gaming is roughly half of the industry. It's a growing half. That's a good thing. Traditionally, 5 years ago, it was console games. PC games is still doing really well. But if you look at their kind of year-over-year numbers here, maybe not as much growth as you might want. And if you're starting your career, perhaps you want to be in the places that are growing now, as opposed to the places that are shrinking, but maybe not. Maybe you really like PC, maybe you really like console. The mobile space is super competitive. Many people have argued it's one of the most competitive spaces in the world. There's a number of reasons for that. The biggest being low barriers to entry. Basically, anybody can start a gaming company. You don't need to spend $30,000 to get approved by Microsoft. And it's both a blessing and a curse in that if you've got a brilliant idea, you can walk in there, but there's also not much stopping somebody else from taking your brilliant idea and running with it. Kabam, yeah, there's a bunch of companies in town. So let me back up one step. I'm presenting this as myself, not, heavily sanctioned Kabam presentation here. So the lawyers haven't gone through the numbers here. These are all numbers you can get off of LinkedIn. So I can tell you the Kabam number, we list 800 employees, is spread over all of our different studios. Vancouver's kind of in the 400 range. But yes, we're a fairly large company in Vancouver. Electronic Arts is obviously biggest. Their campus is not far from here, and there are lots of good, smart people there. There are a lot of other fairly large companies in town, Relic, Blackbird, Phoenix Labs. Relic has is partnered closely with Microsoft. They're mostly doing PC games, but console as well. Blackbird has done console, but they're also doing mobile. Phoenix Lab is mostly PC. Microsoft Game Studios is obviously console mostly, but they have a PC version of their game as well. Eastside Games is mobile free-to-play only. And then as you get smaller and smaller games, same things keep happening. Thinking Ape is mobile only. Clay is PC, not free-to-play, but they have some of the free-to-play elements in it. You get the idea. So game industry in Vancouver kind of matches the previous slide in that there are some mobile free-to-play stuff, some console stuff, lots of companies to look at. Happy things. Who am I? I graduated from SFU. I'm not even sure they have this degree anymore, but whatever. A long time ago, I started in computer science. I switched over to engineering because they had robotics, and that was just super cool at the time. I did a co-op. I was in the co-op program. I went to Electronic Arts. I worked on their Reboot game, which you have never heard of and was terrible. But it was a hometown thing. Reboot was made by a company at the time called Mainframe that is now called Rainmaker Studios. The CTO at Mainframe, Dave Fracchio, was a professor here. There was a lot of connections between SFU, Electronic Arts, and game industry in Vancouver. At the time, Electronic Arts was maybe 400 people in Vancouver. It got to be hundreds and hundreds and hundreds. So you can see I was at EA for a long time. They were really good. They were a lot of nice people working on really cool games. They'd really kind of figured it out business-wise. They were shipping a game every year. They still do, obviously. And many of those games, you'd have hundreds of people work on them. They'd make a pretty good game. Out it would go. Sometime around the release of mobile, so this is like iPhone 1, 2, EA kind of had some pretty heavy-duty threats. They were there was this fight between Microsoft and Sony about which platform was going to come out on top, and basically nobody knew, so everybody got a new iPhone, and that was pretty hard on the revenue. EA went from easily 15, 20 titles being developed in Vancouver down to 7 in the space of about a year. EA lost hundreds of employees in a short period of time, and it was rough. It was, games industry is not just milk and honey smooth all the way through. There were lots of small independents. I was working at a company called Slant Six with a bunch of friends that I had worked with before. Almost everywhere you go in the industry nowadays, you'll probably see somebody that's worked at EA. Finding people that have not worked at EA is kind of a badge of honor, because EA's influenced a lot of this industry. Worked at Slant Six for Resident Evil, which is a Capcom IP. That company went out of business, which was partly because of those random crappy mobile games. Turns out if you make crappy games, you don't make a lot of money. I went to work for Capcom. Dead Rising is a packaged good game, PC and consoles. And it turns out their business model was in trouble too. It's really hard to convince somebody to buy 3 zombie games for the same console. So they eventually went out of business as well. And then I started at Kabam. Kabam at the time was about 200 people. As I've said, it's quite a bit larger nowadays. They have a title called Contest of Champions, which is a huge amount of revenue for them. They need to make new games, so they put me on a new game called Disney Mirrorverse. And believe it or not, it's been 5 years on the same game trying to get this thing out the door. And you can see in comparison, it used to be you'd work on a game for 9 months, maybe a year. It wasn't unusual to work on 2 games in 1 year. Whereas nowadays, the amount of effort and time they're putting into games is obviously longer than a year. Okay, before I go into first-time experience, anybody have any questions about industry, blah, 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 blah? I'm more an interruption and get it done right away kind of guy rather than wait to the end. So if you have any questions, just ask. There's not that many people here. The flow is. Sorry? What's the mean by front end or? Good question. So that word front end and back end is probably one of the most abused terms in the industry. So when you're in the web space, front end is generally the web client. In the game space, front end generally means the 2D presentation, which might be either the in-game HUD or the front end select screens. In some games like NHL, you would have like a championship ladder you got to go through, when you play against these guys. And a lot of the presentation for the game is sold in those 2D screens. You just go back into a fight and it's 2 teams and that they do their thing and then you're done. It's the front end that provides you the context of like, why is this match important? Why do I care? Am I trading a player to, solve a problem, these kind of things. So while the front end may not be as exciting as the 3D parts, the front end is often the long-term durability of the game. Like you're going to keep playing the game because of the front end, because of the modes that you have available, kind of thing.
Also kind of there as well. What kinds of things were you in charge of in 2007 under rendering?
So that was a research and development group. At the time, EA, and this happens a lot in industry, that you'll get one group does rendering one way, another group does rendering another way. So as an example, NHL might have a stadium with 20,000 people and FIFA might have a stadium with 60,000 people. And NHL renders their crowds completely differently than FIFA. So is there anything we can learn from one product to the other? So in NHL, every character in the time in the stadium was uniquely animated. You actually had the entire crowd could do cool things, and you wouldn't see like the entire crowd go like this and then like this, whereas FIFA did. It was all the card style interchange. So we needed to talk to each other, but at EA, it's like you're on the 3rd floor, you're on the 4th floor, rendering people would never talk. So part of it was I just went and interviewed each of these departments and made videos of like, what are you doing? What's cool about your product now? So even back then, FIFA, for instance, was doing dynamic range in their cameras. So you'd have a tunnel scene where you're coming into the stadium, and then the camera would look up and the scene would just blow out white because of sunlight and all this kind of thing. And you'd get that kind of hero moment as your people come out and the camera changes exposure, the tunnel gets dark, people get light. That may not exist so much in NHL, but in an NBA game or a baseball game, that may actually be something useful. So as a company, we were doing a lousy job sharing these technologies and even these ideas from one game team to another. So my job was to try to get them to share this kind of stuff. Didn't work very well, but we tried. So we were looking at technology like face in the game. So building a consistent face in the game system so that you could make your face in one title and then just reuse it in another title, not have to build it again, that kind of stuff.
Would you say there was a rivalry between Electronic Arts and Activision Blizzard as well because of all the Warcraft at that time? Because that was like really huge at that time.
Yes, it was. So I was on FIFA for a while there. There was a rivalry between us and Konami. We knew people at Blizzard and we just envied them. Like they were making money like crazy. We had no game that had an equivalent amount of money. We kind of, at the time, and you know, you're naive back then, we thought it wasn't, they were basically abusing the industry because we had this model that people would buy a packaged good game, $80, they'd play it for a month or two, they'd put it down, they'd spend another $80 on another game, and then, you know, we would, because EA was big, we would be a fair number of those games. Whereas World of Warcraft or EverQuest before that, you know, users were just sitting in the same game for months. And we're like, well, they're not buying NHL if they're just playing EverQuest all day or, you know, World of Warcraft. So we kind of thought, you know, they're breaking the model here. What are you guys doing? But of course, you know, at the time, you know, we started from a packaged goods model and that's all we understood. And the idea of like casual gaming, like all that was just, didn't exist back then. Yeah, Take-Two, they had an NBA franchise. They eventually won the NBA franchise. That was a fight back and forth. There were other Take-Two as an example. EA got an exclusive license to the NFL. Take-Two had an NFL game. So that was a difficult thing. Baseball, Major League Baseball gave an exclusive license, I think, to Take-Two, but I don't remember exactly who it was. But Nintendo also had a license that was grandfathered in. So, you know, we looked to see, could we get the Nintendo license? You know, all these kind of goofy things. In the 2000, like the FIFA era, the FIFA back then was particularly crappy. And Konami's Winning 11 was very good. And EA, their marketing was unbelievable. So that was the same era that Harry Potter came out. So they were telling retailers that if FIFA doesn't get good placement in your store, you will not get the first shipment of Harry Potter. And this is the kind of crap that a big publisher can do in a packaged good world. There's no equivalent to this in the Apple Store, kind of. You can pay for placement, but it's not quite the same as what was happening back then. Go ahead.
You just pointed out the rivalry between Konami and FIFA in regard of PES and FIFA, and you said that at some time, like PES was more thriving than FIFA. Up until 2013, 2014. So what was the turning point? I mean, what led to now that FIFA's #1 soccer game and PES is like second or even third?
Well, it's probably about 10 different components. So when I worked on FIFA, which is 2013, 2014. Sorry, 2003, 2004, EA is trying to maximize the revenue. They're trying to hit as many console generations as they could. So you'd have a PlayStation 2 version of the product and a PlayStation 3 version of the product. And you would kind of stretch out as long to cover both generations as you could because that's how you would maximize revenue. Whereas a game like Pro Evolution or Winning 11, these kind of things may have targeted specifically the current generation of technology, and we're going to ignore the previous one. So at the time, EA was using an animation model that they referred to as railroad tracks. The guy would walk forward, then turn, then walk, and it just was not responsive enough. It didn't feel good. Whereas Konami had moved on to a better model. The same thing happened in basketball. And the reason that they used that railroad tracks model was that it was energy efficient. You could do that in still run a very short CPU cycle. So you got frame rate on low end devices. At the time, we were working on FIFA, and hardware was capable of floating point math, but just barely. Like PlayStation 2 was the first hardware that had floating point math, and the underlying engine was all built in fixed point. And there was sometimes you would run into code that was like if-def Sega Saturn, and it's like, well, this code's still here, but of course Sega Saturn didn't have floating point processing, so you would have to come up with a different way of writing it. So there's a lot of legacy code and then design so that you could support multiple generations. And yes, at one point the strategy, hit as much as you could, but somebody else would hit the latest and then you wouldn't feel so good. that went the other way. One of the Need for Speeds that we had, we exclusively targeted the later generations, and it turned out we left a lot of money on the table. We should have targeted, like this was PlayStation 4, and we should have targeted more on PlayStation 3 because there just weren't enough installed PlayStation 4s in the world that you could get significant money. But we had a good looking game, but not enough users. So poopy problems. Okay, first time experience. This is an industry term. You'll sometimes hear it shortened to FTE. Basically what we're looking at is that first 15 minutes of time. There's no like fix it means 15 minutes exactly, but we're looking at, for that user that's never played your game, what is their experience when they first launch it? So before I do that, let's talk a little bit about the context of why we care about that now. So packaged good games, which is still half the market, basically follows this formula. The profit line's a little hard to see sometimes. You hire a bunch of smart people, you make a game, you hype it up, and this was, when we were at EA, this was sometimes really infuriating, is that they would spend more on advertising than they would on engineering. And we're like, just make a better game, it'll advertise itself. But that's not how it works. Like, the advertising component is huge. And that was one of the things that EA was very good at, was getting that marketing, the co-marketing, all these good things. EA would get a huge number of pre-sales. You've heard lots about that in the industry. Console games take months and months for approval. EA was quite good at this. They would have a good relationship. We knew what was expected when we made a console game, pre-test all that kind of stuff. And then you release the game. You hopefully collect a whole bunch of money. You apologize for your mistakes, of which there will be YouTube videos, and then you start making patches. The curve of money here is, with most packaged games, not like an online game, is that you would get a big burst of money. That first weekend basically tells the story of the rest of your product cycle. It's a huge amount of money, and then there's a long tail. When EB started reselling games, that changed the shape of the tail. It used to be that EA would make a lot of money based on that tail. It would be, people buying games 6 months later, a year later. Once you could buy them used, that whole part deflated, which was part of the revenue stream, which is part of what EA ran into in problems. One of the challenges with this packaged good model, especially with resales, is that after 4 weeks, you're just not making that much more money. You're not selling that much more packaged goods. So how much inducement is there for you to go fix the game? And it's going to cost you a lot of money to get that thing through first party, the Sony or Microsoft or whatever. And then they'll get it out there, but most of the players that bought your game have already sold it. So it's a really much point. Maybe you should just work on next year's game. And that leads to kind of the, product quality may not be so good. And at EA, they're tracking the Metacritic scores and all these kind of things year over year, but there's not much they can do about it other than try to make a better game. So let's talk about other problems you run into. If you're an indie, you're trying to build your own game, which is awesome. You run into a whole bunch of problems. The first one's a money problem. If you've got a packaged good and you want to sell it in Brazil, and there are a ton of people in Brazil, if you try to charge US prices for it, you're going to price out most of that territory. It's just too expensive. Conversely, there are some people in the US that have a lot of money, or Europe, in the UK for FIFA as an example. They want more experience. They want to play your game more, but they can't interact with it other than they bought the packaged good. So from an economics point of view, this is kind of a problem. We're not taking advantage of the market as well as we can. That marketing cost, especially as an indie, that's huge. How are you going to get anybody to know your product even exists? PC piracy is an issue. Consoles had piracy issues, some years worse, some years better. Steam has definitely helped with distribution. If you're an indie, that's a great platform to work with. But you still often need a publishing partner, which is taking a fraction of your revenue. And these are all difficult business problems sometimes. So how does mobile games change this? So roughly, we still have the same plan. We're still going to hire a bunch of people. They're still expensive. It's not like the people that build mobile games are any different than the people that build console games. This hype it up that's kind of a bit more optional now. We can put it in the store. If it sells well initially, it can build its own hype. If it doesn't sell well at all, you don't waste a whole bunch of money advertising for a game that turns out to be a flop. Pre-sales, still a thing, but you're not selling anything, so you can get pre-registration. So that's cool. Games are easier to get out the door. Google and Apple generally approve in 24 hours. Every once in a while, they take a week, but generally 24 hours. Your game is free, so how are you going to get some money? That's a bit of a problem, but we'll come back to that eventually. We'll put in some offers or something. But this last step for an engineer is quite important, because now that you're in the store and new people are coming every week and continue to come every week, and your industry is all about that long tail, you want to care more and more about that product. You want to keep that product going for year 2, year 3, year 4, because you spent a lot of money right at the beginning building this thing. You're not going to make another packaged good version of it for next year. You want to spend the effort to make this thing suck less. So what we're going to talk about today is trying to make the game suck less. Just put the effort in. Okay, I might come back to this. I just want to show you something. So, how do I get out of this? Okay, so this is Unity. I'm assuming most of you guys have used Unity, seen it at least. Unity's free, kind of. You can download it for free and play with it for free, which is awesome. If you make a good game, Unity probably comes knocking for money. But at our level, we do pay for a Unity license. There is the option out there to buy source code for Unity. It's a blessing and a curse. Let's just go with that. It's a mixed bag. It'll take a minute here to launch because I'm on VPN and all in the middle of nowhere. So this is not what our video game normally looks like. This is us just getting ready to launch our game. So we have a whole bunch of servers. All of our games require servers to log in and do validation. This is part of that offers thing that if you were to make a game that is free to download and doesn't connect to a server ever, you're probably not going to make much money on it. So we have a bunch of servers. We have a whole bunch of options down here. So I'm going to make myself a new user. So I'm going to pretend I'm on a fresh install here, kind of, and then I'm going to play. So imagine you just downloaded our game on your phone. Here's your first choice. Pick your language. What we find is every time you give a user a choice, you're also giving them the implicit choice to leave. So yes, we will give them the choice to pick English. Kind of missing textures for security reasons. I can't show you the latest characters and that kind of thing because they're not out yet. But when they are, that would have a real texture there. So we're going to play into the game, and you can see we got this logging in spirally thing that's kind of slow. Oh, we got some story. So I'm not going to go through the whole story here. If you really want to play it, you can just go to the store and download Mirrorverse, and you can play. So again, can't show you this character that's not yet released. This is taking a long time. Oh, there we go. Rapunzel, I kind of recognize her. So you'll see I'm going to skip. You will find that many users skip the dialogue. I don't have the audio on because it's kind of a little weird in these kind of situations. So you have to imagine I'm playing on a mobile game, on a small device. I'm going to use the mouse to kind of emulate that. It doesn't work very well, and we'll get to that in a second. So these are kind of imagine my virtual thumbsticks. I'm sure all of you guys have played free-to-play games before on your phone. You have some idea what's going on here. So you can see we're kind of telling the user a little bit of a story. We have a world. We're moving the characters around. We're telling the users what to do. And there's some questions here, like, what do we tell them to do? We do kind of help them, so it's not enough that they just tap the button. They actually have to do it correctly. And this is, there's trade-offs here. Can we just make a game that's like, oh, I'm just going to tap around and if some cool stuff happens, awesome. That might be appropriate for some markets. It might not be appropriate for this game. We need to figure that kind of stuff out. So you can see we're a wave-based game. We've got a bunch of different things happening, like you attack a goon, you attack another goon. I'm kind of left on my own to fix myself here. But this isn't instant. This is, it's taking some time here to teach me how to play the game. Oh, big bad guy. I'm kind of scared. Oh, Mickey's on. This. Got some nice special effects and cool things. Hey, look, it's Mickey. Oh, right, I got a job to do. Let's go do Mickey special attack. Do my special attack. Oh, he got us. I have to say I suck when I'm playing on the trackpad. Okay, so we'll get some story just in time. Always like to be told I'm doing the right thing. So, okay. Oh, look, I got some stuff. Nice. I don't know what that stuff is. I don't know what I do with it, but yeah, maybe it'll show me. Great. I did great. Feel good about that. So now it's giving me direction. So we might refer to this area as the front end. You can see there's, we would call these tutorials where it's telling me how to interact with the game. We're going to do this throwy thing, pick, toss it into the game. And I get to pick a character. Now there's quite a bit of text here. There's quite a bit of story that's going on, and I get to make a choice. Hit confirm. Kind of got a dance here, trying to make me feel good about the choice that was made and the hero that I got. And this is kind of like the underlying mechanism of many of these games is that you want to collect heroes. So you want that kind of hero reveal moment to be meaningful, but you don't want to spend, you don't want to put on a parade for them. But I'm going to press the play button. I'm going to go enter here. And at this point, I am done what we would consider the FTE. So that took in the order of about 5 minutes. Anybody have any questions about what I just did there? What that moment? So this is the moment we're here to talk about.
Yeah. I saw that at the beginning of the game there was a cutscene to establish the story, and nowadays we see like some games integrate this cutscene into the gameplay. So you play the game like God of War, for example. You start the game and you have the cutscene running.
Yes.
So, in your opinion, which method is more engaging to the player in terms of experience?
Good question. So we are a mobile free-to-play game. I'll get to that in just 1 minute. I'll come back to it and we'll talk about that. Okay, so I'm going to put this away for a minute, and I'm going to start talking about. I'm going to go to the engineering side of this and talk about data, and then we'll go back and answer your question. So if I go to here, this is BigQuery. I don't know if anybody here has played with BigQuery. I think it's also free. You can create a Google Cloud account. It's not the only big data system out there. There's Cassandra and probably half a dozen others I don't even remember the names of. But basically, it's a database. You can do queries. You can, write normal SQL. So this is our current build number, and I am basically asking a table that has all the events in it for everything that happened relating to tutorials. And I want to know what's happened in the last 28 days. So I'm going to hit run. This is going to go look through a whole bunch of data in the order of hundreds of gigabytes and pull out the relevant data to me. So here's my report. So I'm going to save this, copy it to Google Sheets. Oh, that's not what I want. I want to copy to my clipboard. I'm going to go over here. I'm going to paste this in. Bonk, paste. I'm going to take this other thing here. Okay, so what are we looking at here? When I am playing on my phone, I am passing certain events in the game. So we saw that logo load screen. So right at the beginning, it says Kabam and it says Disney. We got to that cut scene where we got the image and we got to pick. You can see show loading screen for we're going to go into the encounter. You can see we start to run the encounter. We start to go into that loading screen. we start the tutorials, and then a number of things happen within that encounter. The next column here is, on average, how many seconds did it take for a user to get there? And this number up here is how many users actually are still with us. So we're looking at 60,000 at this point, and you can see over time it is declining. And it declines, basically by the minute you are losing users. So we need to try to understand what's going on here. What can we as engineers do to influence this? So back to the original question of, is it better to do a cutscene or to do it actually in the engine, do a story while you're playing it? It's a good question. You can speculate, I can speculate. The only way to know for sure is to try it out. So when we are building any of these games, we build what are called split tests. So half of the users would get the interactive story and context in the game. The other half would get the cutscenes, and we would see which ones retain better, which ones might spend more, these kind of things. There are challenges, there's trade-offs. So if you do the cutscene thing, you have to load some images. If you do it where it's built into the world, you may have to load additional characters, you may have to load additional assets. 3D assets are generally quite a bit more expensive than 2D assets, so you got a load time trade-off. So we need to look at these different trade-offs to make a decision as to which way we want to go, based on the results from the split test. So what you're seeing here, there were actually, and it's a little subtle, you wouldn't have noticed it, but when we did that that game, you may have noticed I got the choice between which of my starters. I picked Mulan, but there were a couple others. That choice is actually split test. We will rearrange the cards there to put them in random order, and then we want to, so we know that it's not just everybody clicks the center. And then we will look to see which characters are users choosing. And we have chosen those characters for initial choices based on user feedback. So we know that users were more excited about Mulan than they were about, say, Jack Sparrow. They didn't understand Jack Sparrow at that point, so we took Jack Sparrow out and put somebody else in. So even though what you see there looks like a normal game, you're actually experiencing split tests already in that period of time. So we have a bunch of data. I'm going to go show two engineering problems that are shown in this data and talk about them a little bit. Before I do that, we've done the BigQuery one. Anybody have any questions?
What was happening at the 9 to 10 seconds, 30,000 users?
Why did they all die? Excellent question. It's actually an accounting problem. This is beforehand, and these users are in these seconds. We don't actually know if you're a returning user or an existing user. So a whole bunch of them just disappear because they're turning out they're actually returning users. So they don't need to go through the FTE. So and you have to really watch the accounting on this kind of stuff because yes, you see these kind of things. So if I were to get rid of that data point, now you can see it recolors and you can say, hey, this 1.97, we lost 2% of our users at this spot. What happens at encounter 0805? Why is it that some users can't get past the spot? And we'll get into that in a minute. Okay, so we did the demos. So let me go back and make a graph just so that we can demonstrate that we can make a graph. I'm going to take some stuff and I'm going to take some more stuff. And then I can insert a chart that looks like a line chart. And yes, you can see there is a decline over time, and you can go through and look for these specific events. So this is, as an engineer, something that I'm going to do and look at the data. So I'm going to go back here, keep going. So one of the things we're seeing is this just general downward trend. We know that some of these drops, like that one that we saw that was 2%, whenever you present the user an option, they might leave. So every time they get off, every time the rails stop, that's a choice that they could exit. So that is one of the things you want to try and build around. You want to build your flow in such a way that you don't ask them a lot of questions, just let them go. But we can dig into this data a little bit more and look at things like frame rate. So I got a fairly nice iPhone. That's cool. Most of Canada does, if you look at the devices. We are targeting the world. We have a ton of users in Brazil. We have a ton of users in Mexico. We have users in Poland. They're nice people. We'd like to give them a good experience. So this data has been randomized to, so we're not telling bad stories about specific manufacturers, but you get the idea. We have a bunch of devices in the left-hand column. Those devices have specific pieces of hardware in them. So the graphics processor, the system on a chip. You can see in some cases, you can see this Bengal system on a chip is used in a number of different devices. But even then, like this Realme RMX, whatever the heck that is, gets 26 frames a second, whereas this one with the same CPU and GPU only gets 19 frames a second. So when we're running the game, we will record all this telemetry. And for the first person that plays their game on that particular device, yeah, maybe they get bad frame rate. But we need to learn from that and change what we do in our graphics in order to better accommodate what their device specifically is doing. And this is something as engineers we can do. We can measure these kind of performance things and then make changes. So as you know, there's iPhone, there's Android. iPhone, but in general, has better hardware than Android. I'm saying a very broad statement there. There is no Android phone that can even touch the latest iOS phone. So from a performance point of view, how much it can render, how much battery time it has, off the charts, iOS is better. If you take a 5-year-old phone, it still will work better than at least half of the Android stuff that's out there. There's a lot of Android phones that are just not at the same performance level. You often hear that Android has 6 gigabytes of RAM, 8 gigabytes of RAM, and that's not available on iOS devices, which is true, but your Android phone won't give you 4 gigabytes of RAM to play your game in. They'll only give you like 1.4 gigabytes. So even though the device has more memory, and that might mean you can switch between more apps, which is cool, it doesn't actually give us as game developers that much more resources. Turns out Android is actually worse for memory in many use cases. As you can see, there's lots of manufacturers. These numbers were true for 1 month in the not too recent past for our product. So depending on which product you make, you may attract a different kind of audience. Is your audience more hardcore gamer or softcore? Is it target more men, more women? That will change the mix here. It doesn't necessarily make the mix worse, it just changes it. Which country you're in, for instance, like Samsung is quite popular in Korea, of course, and most of the Western world, not so popular in India for some reason. Whereas, Xiaomi or Huawei, they seem to do better in India. Motorola, for instance, which Motorola is quite popular in some of Latin America. So yeah, you just get to live with it. So how do we deal with this? How do we change our rendering such that we can accommodate high-end or low-end devices? So I'm going to talk here about, I'm going to show you a couple screenshots and flip between them to show you some of the differences between the different render settings. The top-end render settings, if you were to take a fairly mid to low-end phone, this scene might take 40 milliseconds to render. We only have 33 if we want to be 30 frames a second. So this scene might take 40 milliseconds, whereas the last scene with all the graphics set off might take 5 milliseconds. So we're talking 8-to-1 scale in features that are going on. So what's in this scene? What are the things you should be looking for? You can see the post effects. You can see that flare on the crystal highlighting this bright. You can see this kind of diagonal effect here. You can see dynamic lights in the environment. You saw some particles flying around and those were lighting up things. Our characters have a shadow and they're not touching the ground, so it highlights that. You can see the spectacles interacting with shadows. These things are expensive. They take time and lots of guts to do. This is what we would call forward rendering. So we're no longer computing a lighting path specifically. We're just absorbing the lights when we render things. It simplifies things, cuts down the time by quite a bit, but reduces some of the effects that we can do. So in this particular example, we've turned off shadows. We've turned down a number of things. You can see the post effects are now missing on the crystal. So, it's kind of goofy to take a look at. This is our lowest setting. So this is baked lighting. We're no longer calculating the lighting per frame. We have kind of baked the world lighting. This is a dark place. This is a light place. And then we use that information, but it limits us to what we can do. So again, if you look at the side of Mickey's head here, That crystal and the thing behind it is supposed to be throwing quite a bit of light, but in a baked lighting, you can't see that reflected on the character because we don't recompute the lighting. When you look at his cape here, you can see it's kind of chunky, whereas a previous one, the cape's nice and smooth. So how many bones do you consider when you're weighting the geometry for his cape? On high-end device, you're using 4 bones, which means more memory accesses. On a low-end device, you use 2 bones, less memory access. You can see here, you kind of got what they call vignetting. The whole scene is kind of darkened in the corners. It's kind of a filmic effect. Whereas in the baked rendering, there is no full screen effect because again, that takes CPU time, GPU time to do all the rendering and all that kind of stuff. So that is examples of features that we can turn off that we built ourselves so that we can get better frame rate on lower end devices, but make a better looking scene on higher end devices. I've been showing you the game in the editor, and I just want to highlight that the editor nowadays is wildly different than devices. The graphical capabilities, it's like 100 to 1 between our worst and best devices. The editor is generally above even the best of what we get, like better than an iPhone X, because it has a huge GPU in it. So, you might get something that looks awesome in your editor. When you get it even on the best of phones, it's not going to work very well. The language stuff is amazing. So Unity runs in C#, and when you're running in the editor, you're running in Mono, which is their emulation of the C# environment. When you build for a target, they actually convert it into C++, and the code is just horrific to look at, but it runs faster, and it does have some differences in behavior. Even things like how floating point numbers work is different, which is kind of fun. We do a lot of, you have to build it for a phone. Your PC does not have a phone interface. The screen's too big, even if it had touch on it. So you need to rebuild for that kind of thing. And network behavior is different as well. So it's if you are building your own games, make sure you run it on a device from time to time, ideally more than one. So we looked at that first example here where we have this general decline. We're blaming that on frame rate. Here's another example. You can see there's a specific drop. You can see there's one, let me move my mouse here, this one step here where we're going down. And we can isolate it in the data. We can say, hey, between this step and this step, it took us, I hope they're okay, roughly 28 seconds to go from one step to another. And, that's a lot of time. And we can look at this from what's this build, what's the previous build, and see if there's a difference. And you can see in this example, I've highlighted the data from 22.1, the data from 22, and you can see this got much worse. So this is now a software engineering problem. How do you release software reliably? And you're still making changes, you're trying to improve things, but you need to make sure that your changes don't break other things. So, yes, I have 15 minutes left. Any questions? And then I'm going to say one more thing about recruiting, and then I think we're done.
I have one small question for the both of us, right?
Yep.
Do you ever have rendering features that you think or people think would be a cool idea, but they only work for the high-end devices?
Yes.
And are there techniques to make them kind of work a little bit on smaller?
So we had a funny example of this actually. Christmas was not that long ago. So we had a special event that had snow in it, and snow is awesome. Everybody likes snow. It looks cool, gives you a good sense of depth and all that kind of thing. When the artist built it, they used our 3D particle systems, which uses the GPU to render them. Because it uses the GPU, you can have lots of it. Looks great. And there are people that have iPhones, and it looks great on their iPhones. Then we did the math, and turns out only 30% of people could see snow, because the other 70% don't have GPU particles turned on because their devices can't handle it. They could handle it, but they can't do everything else and maintain frame rate and not chew up the battery. So that was a bummer. It turns out we could recover some of those devices and get them showing snow where previously we were just giving them a lower setting than they should have had. But ultimately, yeah, the artist had to come up with an alternative implementation of snow using existing budgets so that they could have both their really pretty GPU particle snow and a lighter CPU-based snow for devices that couldn't handle or couldn't render GPU snow. So as an example, and these things happen. The flip side, when you look at a game like Contest has been in the market for 7 or 8 years. So those graphic settings that were for a low-end device 7 years ago are basically obsolete. They don't, like, nobody has a device slow enough that would use those settings anymore. But artists were still building graphics for it because, you know, nobody told them not to. So yeah, when you have a game that lasts a long time, you have to look at this slowly inflating set of device specifications.
Yeah. So apart from the graphics part of the game, I mean, like the 3D models and the particle systems, stuff like that, are there like any techniques to optimize the game in terms of the mechanics itself? I mean, the gameplay or the code?
Yes. Trying to think of a story I can tell you that's reasonable. So modern phones all have lots of cores. Even recent iPhones have at least 2, but generally more. Many of these things can run in parallel and multiple threads. So let's say you're doing a strategy game and you want to have the concept of territory control, or you're doing motion through the world and you want to move your guy through a safe space so he doesn't get hit on the way through. You might do there's a bunch of different diagrams you can do to represent who owns the space. The one I can think of off the top of my head is a Voronoi diagram, but you do basically, these are the territories that are controlled by this character, and then you go and compute a path through that space. That computing the diagram can be computationally expensive and can be done on another thread, as an example. Go ahead.
I know you said that for like overseas school for UA, like the NHL games, like the product, and other people want to not really talk about it.
Yep.
For this game, I did notice it's pretty similar to advanced champions, like with the crystals.
Yes.
So, how much influence do those games?
So yeah, it would be expensive for game companies to build a brand new game every time. And there are a couple things that happen there. So there's the obvious, somebody's got to write the code again. There's the less obvious, somebody's got to write all the tools again. So let's say you're doing a fighting game, you need to keep track of, like, when am I actually doing damage? When can I block? All these kind of, you know, metadata that goes along with a fighting game. Put on particle effects, put on sound effects, all these kind of things require timing and synchronizing. So you have the engine code, you have the tool code to build all that data, and then you have a whole bunch of artists and designers that use those tools. So if you do unique code for every game, you have the cost of code, tools, and training to get all those people doing the same thing. So you want to recycle as much as you can, but not use it to limit your product. So if you just took Contest and recycled it and tried to make every new game a copy of Contest with a small amount of change, you probably wouldn't succeed in the marketplace because people would see it as, hey, it's just a clone of this other thing. The mechanic of, hey, it's a crystal, that's probably not enough of a clone that somebody thinks, yeah, you just ripped off this other game, I'm not going to play this one, because I just showed you play one versus several and you have a 3D world that you can move around in, which is different than what Contest was. So we're kind of picking our battles as to what kind of things we'll recycle and what kind of things we need to make unique for this game. Caleb, does anybody else have questions on the vast internet out there?
No, I haven't got any.
Wow. It's impressive. The people here seem to care a lot more than those people.
Who would have thought?
Yeah, who knew? I got 6 minutes left. I'm going to do my pitch and then I'm going to walk away. I am not a recruiter. I suck at it. There's a guy named Ryan Cheng. He works at Kabam. He wants to talk to you. He is a software engineering recruiter. That's all he does, hires engineers. We have on my team a co-op every term. Caleb was a co-op at Kabam. We just hired another gentleman who was a co-op at Kabam before he was hired full-time. If you're asking how do I get into the games industry, co-op's a great option. I recognize there are not a lot of good entry-level positions in the game industry. It is hard to get that first step in. Some of the smaller companies may have more of those steps. Kabam does try to hire new grads, but unfortunately our needs don't always match with school cycles. So, you know, it might be September and we're looking for new grads, but of course they all graduated in April, and, you know, these things can be a problem. So a couple things. Number one, make sure you're on LinkedIn. You would be amazed how many people I talk to that aren't on LinkedIn that want a job in the games industry. Games industry is all LinkedIn. Every company I know of hires through LinkedIn. So if you're not on LinkedIn, like, you're not even trying. The second one is basically find the recruiters and make friends with them. Like, you can, what's the right word? So I forgot the verb. But basically, make them one part of your circle. Ryan wants as many friends as he can have, and that's his job. Every day, people like me will go to Ryan and say, "Hey, I need two more software engineers that can do this kind of thing. Can you find me somebody?" And he's going to use LinkedIn to go find those people in the social network. So I definitely encourage you to get on LinkedIn, add Ryan Chang as a friend. If you want, go to kabam.com, look at careers. It's generally more senior people. We do sometimes have positionings for new grads, that kind of thing. It's unfortunately not that common, but we do. It does happen. So, anybody else have any last questions? Anything else we can?
Yeah. You just mentioned that there are not like many entry level in the game industry, and that's totally understandable because, I mean, you know, like the amount of challenges there are. But in your opinion, what is the level of experience that you need in order to get started? And in what areas? Because
it's a good question. It's funny because there's this gap that when we hire somebody as a new grad, they don't have any bad habits. I mean, maybe they do, but it's good enough. And they're usually super enthusiastic. By about year two, like if they've got 2 years in the industry, they've worked somewhere else and they have some habits that we don't necessarily appreciate. And their enthusiasm may be waning a little bit. So there's actually this valley that happens as people get older, that they're a little less attractive. And then, you know, after about year 3 or year 4, they actually become more attractive again because they have enough experience. They've shipped something and they have that kind of thing. It is too much to try to swallow the whole games industry. You can't be good at everything. What I care about more as a hiring manager is that you're passionate about something. I don't really care what. Like, maybe you really like gameplay. Maybe you really like physics. Maybe you really like networking. I don't care. Just be good at something. So, you know, maybe it's, you know, you're working on a school project and you kind of delivered 200% of that project. Maybe you did a co-op term and you worked on something dedicated and, you know, had a good time with that term. Maybe you're working on something with some buddies and you did this piece. As long as you've got passion about that piece you built and you can talk about it intelligently, like, I made this choice instead of this choice. I used a tool to determine that this was sucking and needed to be improved. Like, just be good at something. After that, you know, we'll work it out. I know it's not very specific guidance, but I'm hoping everybody's got passion for something they see is exciting, and whatever it is, chase it. Like, pursue it more, get good at it, because that's what we're looking for when we're hiring people, is somebody that is going to sink into a problem for, you know, months potentially to make it suck less. Cool. Go ahead.
What kind of experience would you be looking for like a co-op, like maybe that?
Yeah. So co-op positions, we're generally looking for some project. So our concern is that we're going to let you loose in our code base and you're not going to know how to interact well with others. So if you've had some experience with Perforce or Git or some version control system, you've worked on a project that has the concept of milestones or releases or something like that, that's something we do look for. And then we look for that passion piece. Show to me that you care about anything. We'll take it from there, kind of thing.
So this is a more general question, but do you have any like rules of thumb developed, relating to like game development or even start?
I don't know. It's harder than it looks. I don't know. Really depends on the problem. So as an example, I did pipelines for a long time. Textures take about 70% of your loading bandwidth. There you go, rule of thumb. I don't know how useful that is, but that's an example of whenever we're looking at trying to improve asset speeds, one of the questions we look at is like because textures are 70% generally of your load volume, that's where you go first to try to find something you can make savings on. If you can make the texture smaller, loading will go faster, that kind of stuff. So I don't know. I'm sure there's lots of little bits and bobs here and there, but it would need to be more specific.